Bismillah ar-Rahman ar-Rahim. Assalamu alaikum, students.
Walaikum salam.
Walaikum salam.
So we were studying this chapter number 5, and in chapter number 5, we are solving the problems of this chapter number 5. So last time I have solved this problem and also this problem. Now see this problem maybe. So in this problem, if mass value is given and this value is this value is 6 kg. This is given. This is 6 kg. And what is the tension in the string 1? This is a question. The string 1 is this one. And this is string 2. And this is tension T2. And this is tension T1. So we need this value. To find this value, first we draw the arrowheads of the tension. This is the point where it is attached, and this is the tension direction, and this is the tension direction. And then you will make the components. So draw the line and make the components along this line. So this component will be in this direction, and this in this direction, and this will be in this direction. So this component will be what? This component will be T2 sine of 60. And this component will be T1 sine of 30. And this component will be T2 cos of 60. And for this one, it will be T1 cos of 30. And the downward force is mg. Now we want to find the tension T1. To solve this problem, what you will do? So you will write the equations. The two equations along x-axis and along y-axis. So x-axis is this one or this one. So along x-axis is T2 sine of 60 is equal to this component, and that is T1 sine of 30. Then we write the equation along the y-axis. So y-axis is T1 cos of 30 plus T2 cos of 60 is equal to mg. This is mg. Now we have these two equations. So from these two equations, you can find the value of T1. But first, from here, find the value of T2. So T2 value is T1 sine of 30 divided by sine of 60. So solve this one and put this value of T2 in equation number 2. Put in equation number 2. So when you put this in equation number 2, it will become T1 cos of 30 plus T2. So T2 is this one. It is T1 sine of 30 divided by sine of 60 multiplied by cos of 60. This cos of 60. So cos of 60. And this is equal to mg. Now we have all the equations clear. So here we can make a common of T1 and then solve for others. So this is cos of 30 plus sine of 30 divided by sine of 60 multiplied by cos of 60 is equal to mg. So if we put the values of cos of 30 and sine 30, sine 60, cos 30, like this one, cos 30 is 0.866 plus sine 30 is 0.5 divided by 0.866 multiplied by cos 30. Cos 60 is 0.5 and is equal to mg. So m value is given here. It is 6 kg. So 6 into 9.81. Now, when you solve this one, you can find the value of T1. It is around 51.00 Newton. So this is the answer. The answer is 51. Okay, after this, see another problem. So in this problem, the mass is hanging at this point, and you can see that it's making an angle 40. I extend this line and extend this line. And here the tension is this one. This is T2 tension, this is T1. So you can make again the components. To find the components, this is in this direction. So this component direction will be this one and this will be this one. This component is T1 cos of 40 and this component is T1 sine of 40. So here you can make the components this, and this is equal to T2 sine of 40. And this component will be T2 cos of 40. Now the components are clear and this is mg. Now we will write the equation. So first write the equation along x-axis. So along x-axis equation is T2 sine of 40 is equal to this one, T1 cos of 40. And now write the equation along the vertical direction. So vertical direction is upward here. And this upward is T2 cos of 40. And downward is mg is equal to mg plus this component. And this is T1 sine of 40. Now again, we have two equations, equation number 1 and equation number 2. We need T1. So find the value here, T2. So T2 is equal to T1 cos of 40 divided by sine of 40. Now you can put this value again in equation number 2. So equation number 2 is what? Equation number 2 is T cos of 40, T2 cos of 40. So T2 is this one. So it is T1 cos of 40 divided by sine of 40 multiplied by sine of 40. Cos of 40. Cos of 40 is equal to mg plus T1 sine of 40. Now you can solve this equation for T1. So to solve this equation for T1, it will be T1 cos square 40 divided by sine of 40 minus T1 sine of 40 is equal to mg. Okay. So here you can make the common T1 cos square 40 divided by sine of 40 minus sine of 40 is equal to mg. Now you can put the values and solve it for T1, and this is equal to, I'm just writing the answer, 40.07 Newton. So this is the answer. So in this problem, the problem is you have to first find the components and then write the equations along x-axis and y-axis. Okay. After this, let's see this problem. If alpha is 40 and beta is 60 and m is 4 kg. So m value is, this is the downward. So here you can make the components, this component, this component, this component, and this component. If this is alpha, this is also alpha according to geometry. This is beta, this is also beta. Now write the equations. So this is T1 and this is T2. T2 and T1. So this component will be T2 sine of beta. And this component will be T2 cos of beta. And this component will be T1 cos of alpha. This component will be T1 sine of alpha. Now the components are clear. Now you can write the equation. What we have to determine? We have to determine T1. Determine the tension in the string T1. So to find the T1, we should write now the equation. So equations will be what? So this is vertical, and this is also vertical downward, upward. So two are upward and one is downward. So I'm writing the equation. T1 sine of alpha plus T2 sine of beta is equal to mg. This is first equation. Okay. And similarly, you can write the second equation along x-axis. This is negative x-axis, this is positive x-axis. So they are equal, so you can put the equal. So this is T2 cos of beta is equal to T1 cos of alpha. From here, you can find the value of T2. So the T2 value is T1 cos of alpha divided by cos of beta. So this value of T2 put in equation 1. Put in equation 1. So when you put it in equation 1, then you will get T1 sine of alpha plus T2. Here you should put all this equation. T1 cos of alpha divided by cos of beta into sine of beta is equal to mg. Now you have alpha, beta angles and m value is 4 kg and solve it for T1 again. Sine of alpha. Alpha is how much? Alpha is 40 and beta is 60. So alpha is 40 plus T1 cos of alpha 40, cos of beta 60, sine of beta 60 and mg. M is 6. I think 6. Sorry, 4. It is 4. So 4 into 9.81. So you know this value, you know this value, you know this value, solve it and take the T1 common and this answer will be around 20 Newton. So this is a question. So here in this question, again see that you have to make the components and solve it. Okay. Now we have block that is placed horizontally and find the acceleration. So acceleration is normally defined the F net force divided by the mass. So this is the equation, but here the force is acting in some direction. That's why we have to make the components, this component and this component. So this component is F cos of 30 because here angle is 30 degree. Okay, so you can write the equation F cos of 30 plus this force, this is all in the same direction, is equal to net force. Net force means MA. F is what? 20 into cos of 30. Cos of 30 is 0.866 plus 20 is equal to M. M is 5 kg into A. Now you can solve it for A. So A value will be 30. If we solve this one, answer is 37.32 divided by 5. And A is equal to 7.46. This is the answer. Meter per second square. So 7.46 means this is 7.5. This is the answer. Okay. After this, here the forces are given in vector form. The question is, if the only forces acting on a 2 kg mass are F1 and F2, what is the magnitude of the acceleration of the particle? So we have to find the acceleration. So acceleration is force over mass, but we need the total force. Total force is 3I minus 8J plus 5I plus 3J. So you can solve this one. This is 8I minus 5J. This is force. Now you can find the magnitude of the force. 64 plus 25 and under root. And this is 89 under root. So find the acceleration. acceleration is 89 under root force divided by the mass 2. So when you divide it by 2, answer will be 4.7 meter per second square. So this is the answer. Okay, after this is the same type of problem. You can see, make the components here and here. So this component is F sine of 40, and this component is F cos of 40. And this is F. Mass is given. So write the equation F plus F cos of 40 is equal to MA. So just put the values of F 4 plus 4 into cos of 40 divided by mass. Mass is 2 is equal to A. You can solve it and get the answer. And A is equal to 3.53 meter per second square. This is the answer. Okay. After this, the block is now placed on an inclined plane. The block is placed on an inclined plane. Okay, students, if you have any question, you must ask, because your response is slowly finished, which I am feeling. Yes. Hello.
Yes, doctor. I think all the questions clear.
Yes, if it is clear, then it's very good. But the other students should also learn, and because you have your midterm exam, and if you cannot understand, you cannot solve the problems. Okay, so in the last question, you can see the blocks were placed horizontally. Now the block is placed on an inclined plane. So when it is placed on an inclined plane, then the things will be different. So what kind of difference exists? Let's see. A block is pushed up on a frictionless 30-degree incline by an applied force as shown in the figure. If force is 25 Newton and mass is 3 kg, what's the magnitude of the acceleration of the block? So actually we have to find the acceleration. So acceleration, you know that it is F over m. Okay, but here problem is the F. F problem is Y. See, this is the force is acting in this direction and make the components, this component and this component. So this component will be F sine of 30 and this component will be F cosine of 30. But there are some other forces acting on this block. You know that in the horizontal case, it is like this one, but it is in this case. So it has two components again. So this is the weight or the mass of the body, and this is the normal reaction, and this component and this component. So this is 30. So this component will be mg sine of 30, and this component will be mg cos of 30. So I want to write the equation. You can see that this component direction is upward. This component direction is downward. So what you will do? F cos of 30. First, because it is moving up, minus mg sine of 30. Okay. And this is equal to net force. Net force means MA. Now you have all values. F is 25 into cos of 30, 0.866 minus M. M value is 3 into 9.81 into sine of 30, 0.5 is equal to 3 into A. So you can solve this one and divide it by 3. So you will get the answer 6.935 divided by 3. So this is equal to 2.31 meter per second square. So in this way, you will write the equation. So here problem is what? Problem is writing this equation. If you understand, then it's very good. Okay. After this,
Doctor, I have
yes,
a question.
yes.
Doctor, we always take the numbers from x-axis, not from y, right? Because it's always equal me.
Yes, because the body is moving up here. When frictional forces exist, you will see, then we will make the numbers in the y-axis also. Okay. Because in the frictional forces, you know that friction is what? Mu into n. And n is what? N is here. So then we will take this one. And then also take this one. Understand?
Yes.
So in this question, this is an easy question. You can solve yourself. Answer is this one. How answer is this one? Then you can make the components. The components is this one and this one. Component is this one and this one. Okay. So if we take this angle, then it will be 60 degree. If you take this angle, then it will be 30 degree. But if you want to make the components along this line, then it will be like this and this. This is component for this side. Okay. And this component is for this side will be what? One is here and the other is here. So this component is here and this component is. From these two components, you can solve this problem. Okay. So from here, it is T1 sine of 30, this one. And this is equal to T2 sine of 60. So sine 30 is what? 0.5. And T2 sine 60 is what? 0.866. So T1 is equal to T2 into 0.866 divided by 0.5. So when you solve, you will see this value will be more than this one. So it means this factor is multiplying with T2. So it means the T1 answer will be more. So that's why T1 is greater than T2. If you want to write the T2 answer, it will be this factor multiply by this factor. So this factor will be smaller. So it will be divided, and when the factor is dividing, then it will be less. Okay. After this is a very important question. And in this question, see, the horizontal surface on which the object slide is frictionless, no friction, still no friction. We are not discussing any frictional forces yet. F is 12 Newton. This force is 12 Newton. It is given. What is the tension in the string 1? This one. We want to find this one. So first I want to solve it with a detailed way. Detailed way is this one. This is 3M and this force is 3F. The tension force will be T1 will be in this way on this 3M mass. Now I want to write 2M mass. 2M mass is this one. It is this, it is this. So if this is T1, then here also it will be T1. Between the two masses, the tension is same. If this is T1, this is also T1. Okay. So 2M is here and this is 2. 2 mean T2. So the T2 will be here. Now I am writing the last mass. Last mass is M. What is this one? And what is this one? This one is clear. This is 2F. And what is this side? This is T2. So this is the detailed way. How many forces are acting or how forces are acting on 3M, 2M or M masses. So you can label these forces like this one. Okay, one thing. Now to solve this problem, first what you will do? You will solve it by the tricks. The trick is this one. Find the acceleration first. Acceleration is what? The net force divided by the total mass. So net force is what? 3F minus 2F divided by total mass. 3 plus 2 plus 1. 6. Okay. And A is equal to 3F minus 2FF over 6M. Here M. Here M. And F is what? F is 12 over 6M. And this is equal to 6 ones are 6, 6 twos are 12. So 2 over M is the acceleration. A is equal to 2 over M. So first I find the acceleration. Okay. After finding acceleration, now write the equation for 3M mass. You can see it is in this direction. It is in this direction. So surely this whole system will move in this direction. So it means 3F is greater. 3F minus T1 is equal to MA, net force MA. On which mass? On this mass. So this is 3M into A. Now you can solve 3 into F is 12. It is given minus T1, 3M into A. A is 2 over M. So this M will cancel here. So this is 12, 3 is the 36 minus T1 is equal to 3 2s are 6. So you can solve it. 36 minus 6 is equal to T1. So T1 will be 30 Newton. So in this way you can solve this one. And also you can solve it for mass 2M. You can solve it for mass M because already all the equations you know very well. Okay. After this, 3 blocks, if P is equal to 6 Newton, what is the magnitude of the force exerted on block 1 by block 2? On block 1 by block 2 mean you want to find this force in this direction. So what you will do? First find the acceleration. So acceleration is what? The force which is applying, okay? And what you will do? The force is applying 6 Newton divided by the total mass. 5 plus 3 plus 2 is 10. And this is equal to 0.6 meter per second square. Okay. And this is 10 kg mass. So acceleration you have found this one. No problem. Now we want to write the equation for block 1. So the force is acting in this way. This is P. The 2 is acting in this way. So we write P minus 2 on 1. 2 on 1 is equal to mass. Mass is what? 2 into A. So P is 6 minus F2 on 1. We want to find 2 into 0.6. A is 0.6. So solve it. So 6 minus 2 into 0.6, 1.2 is equal to F2 on 1. So if you solve this one, this is 4.8. F2 on 1. So this is the answer. So here what you have to do? You have to find this is the force and this force is in this direction on this block. So that's why we have solved for this one. Okay. After this, the surface of the incline. Now you can see the 2 blocks are placed on an inclined plane. This is another game. So on the plane, S is frictionless. If F is 30, this F is 30 Newton. What is the magnitude of the force exerted on the 3 kg block by the 2 kg? So how much force 2 kg is exerting on 3 kg? So the formula is same. We need what? What is the magnitude of the force? So first find the acceleration. So acceleration is F net divided by the total mass. But here F net or net force is not this one, 30 Newton. You have to find this force. How you can find this force? So you can see that this is the weight, this is the normal reaction, and this is the component. One component is here in this way for this block. The other for other block, this component is also in this way. This is 30, this is 30. So this force is acting upward. It is 30 minus. This component is downward. This component is downward. So both component and downward, we subtract these two components from the force. So the answer is, if I write the combined, 3 plus 2 is 5. 5 into G into sine of 30, because this component is actually 2G sine of 30. And this is 3G sine of 30. So total will be 5G sine of 30. And this is equal to mass into acceleration. So what will be the mass? Mass is the total mass. We will take the total mass because here we take the total mass. So you can solve this one. 30 minus 5 into 9.8 into 1 over 2 is equal to M5 into A. So when you solve this one for this, you can find the acceleration. So acceleration will be 1.1 meter per second square. First, we need acceleration. Now we want to find 3 on 2 or 2 on 1. To find this one, you have to apply the equation minus mg sine of 30 is equal to 3 into A. I have taken the second mass because second mass is exerting on the first mass. So you can find 3 on 2 is equal to mg sine of 30 plus 3 into A. So M, you know everything. This is 3 into 9.8 into 1 over 2 plus 3 into A. A is what? 1.1. So you can put this value and solve it, and your answer will be 18 Newton. In this way, you can solve it. So the problem is here, how to make this equation. This is the problem. Okay. After this, now you can see the question with the frictional force. So here first, a block is pushed across a horizontal surface by the force as shown. If the coefficient of kinetic friction between the block and the surface is 0.3, it means it is mu k. Kinetic friction means mu k, 0.3. F is equal to 20 Newton. And theta is equal to 30 degree. And M is equal to 3 kg. So these values are given. So what we will do? We will draw a line, make the components like this one. This is mg and this is n, okay? The block is moving in this way. So we want to write the equation. Now see the equation. N will be equal to what? This component is downward. F sine of 30. This component is downward. I will add this one. So you can find the value of N from here. One thing. The second thing, the body is moving in this way. With which component it is moving? It is moving with this component. And it is F cos of 30 minus the frictional force. So frictional force is always opposite to the applied force. Minus F is equal to MA. So you can solve this one. The force value is given here, 20 Newton. And this is 20 into cos of 30. So cos of 30 is 0.866 minus F. Now this is important. So F is mu k into N is equal to M. And M value is 3. M value is 3 into A. We need actually A. So to solve this one, this is 17.32. If you multiply this one, minus mu k is 0.3 N. So N, you will put this one, this value of N. So N is F sine of 30 plus mg is equal to 3 into A. So putting the value of F, M and sine 30 and G and solve it, you will get the answer of A is 1.1 833 meter per second square. So in this way, you can solve this problem. Okay, this is the same type of problem. It has no problem, I think. This is easy one. You can solve yourself. Okay, these are the problems which is related with the block on the block. You can see this is the block on block. Okay, you have one block and over it another block. You are applying the force here or you are applying force here. Which block is moving, which block, when block is moving, when block is not moving. So we will see and check all these conditions in the next lecture. And next lecture will be the last lecture of this chapter number 5. Okay, if you have any question, you can ask. Otherwise, see you in the next lecture.
Thank you, Doctor.
Okay, Assalamu alaikum.